Okay, we're going to put a wrap or a bow on this little mini unit in chapter 12. I'll finish up section 3 here and the unit all together. Our targets for today is to be able to write a rule for a geometric sequence given a term and a common ratio, and then write a rule for a geometric sequence just given two terms. We did this for arithmetic. We're going to see how to do it today for a geometric sequence. Okay, so if we're going to write a rule, we need to have an a sub 1 and an r. If we're given one of those, generally we can solve for the other. In this case, we're given r and another term. So if we're given r and another term, what we're going to do is we're going to substitute the term in and r in and solve for a sub 1. So a sub 3 equals negative 18, then our n is 3, and our a sub n is negative 18. So I can plug in, I can say, okay, negative 18 equals a sub 1, we don't know what that is. If you want to use x for now, if I haven't done an a sub 1, I'll just leave it in as it is. Equals r is 3, we know what that is, to the n minus 1, or 3 minus 1. I can simplify this. I get negative 18 equals a sub 1 times 3 to the 3 minus 1. What's 3 minus 1? That's 2. 3 squared is 9. A sub 1 times 9. So now I just want to get rid of 9. And I get negative 18 divided by 9 is negative 2. So a sub 1 is negative 2. So to write the term now, or the model, basically we just put that all together. A sub n equals a sub 1, negative 2, times r, 3 to n minus 1. Okay? It's pretty self-explanatory if we're given an r in one term. I'll let you practice with the b down here. A sub 5 equals 324, and r equals negative 3. Okay, so here is a situation if we have two terms, and that's it, no r. We have a formula for r if we have two terms. Okay, it looks kind of complicated, but it's not so bad. If a sub n equals k and a sub m equals j, with m greater than n, then r is equal to m minus n over j minus k. So basically, m is the bigger term here. It's the bigger term. So, because we don't want to have a negative exponent. So if we don't have an r, we've got to have r before we can plug in a term and solve for a sub 1. So we have to start with r first. So if we look at this situation that we have here, 5 is bigger than 3. So this is a sub m equals j, because 5 is bigger than 3, and this is a sub n equals k. That's just going to make our formula work. So r equals m minus n root of j over k. So all I'm going to do is plug in. M, that's 5. N, that's 3. So the 5 minus 3 root, that's going to be square root of j over k. 405 over 45. So 5 minus 3, that's 2. So the square root of, shown on the right, 405 divided by 45, that's 9. The square root of 9 is 3. So r is 3. Once we have r, we can go back and say, okay, let's take one of these points. Let's take a sub 3 and 45. A sub 3 equals 45. That's just like our last slide that we had. So we can say, okay, let's try and find n. Or excuse me, a sub 1. 45 goes in for a sub n. We don't know a sub 1. We do know that r is 3. And we do know that n is also 3 from here. So if we look, we simplify this, we get 45 equals a sub 1 times, times 3 to the second power. 3 minus 1 is 2. That's 9. Divide by 9. So we get a sub 1 is 5. So if a sub 1 is 5, then our equation is a sub n equals 5 times 3 to the, so this up here, to the n minus 1. Okay, we'll try one more because I know that kind of freaked some of you out a little bit. Okay, let's actually go down here. Let's try C, because the first one, if you want to pause up here on B and practice that on your own and go back to it, you can. Let's go to B because that's going to give us something different than the square root this time. So if we look at this and we look at the equation back on the previous slide, M is always bigger than M. So this is A sub M equals J, and this is A sub N equals K. So it's the M minus J, or excuse me, M minus N root to the J over K. So we have to plug in our M, our N, our J, and our K. M is 6, N is 3, J has to be 28, K has to be 224. So we simplify this, and we get the third root of 28 over 224, which is 1/8. So what is the third root of 1/8? Ooh, that's rough. So we go to our calculator. Math. We go down to number 4. The third root of 1 divided by 8 is 0.5, which I shouldn't have to do this, but that's 1/2. So 1/2. Our R value is 1/2. Now we just take one of our values we had here. Let's do A sub 6 equals 28. So 28 equals A sub 1 times 1/2 to the 6 minus 1. So we get 28 equals 1/2 to A sub 1 times 1/2 to the 5th. Well, what is 1/2 to the 5th? If you put that in your calculator, that's 1 over 32. Now if I want to solve for A, I divide by 1 over 32, or multiply both sides by 32, same thing. And I get 32 times 28, which is 896 for A1. A1 is 896. I say A sub n equals 896 times 1/2 to the n minus 1. So I believe we hit our targets. We found a rule for geometric series given a term and a common ratio, and we also found a rule given just 2 terms with our special formula that we came up with there at the end. Have your notes ready for tomorrow. We'll see.